Hello students, we're going to do a solution stoichiometry problem. Just a reminder that we can use a mole ratio when we are going from moles of one chemical to moles of another chemical, which is the basis of a stoichiometry problem. But instead of going grams to moles to moles to grams, in this problem we're going to go liters to moles to moles to liters with a solution. So we're going to use molarity as our conversion factor. But remember, the steps are going to be, we're going to start with liters, use molarity to get to moles, use a mole ratio to get to moles of what we're finding, use the molarity of that to get to liters. So molarity is a conversion factor. We start and end with liters. Here's our problem. How many liters of a 1.25 molar sodium hydroxide solution is needed to react with 0.333 liters of a 1.09 molar hydrochloric acid solution? I know this looks overwhelming, but let's think, what are we given here? We have a molarity for sodium hydroxide, but we don't have the liters. That's what we're finding. So we're finding liters of sodium hydroxide. We are given the liters of the hydrochloric acid and the molarity of the hydrochloric acid. So because we know both of those about hydrochloric acid, that's where we want to start. Now, I do want to remind you, molarities are conversion factors. The 1.25 molar is 1.25 moles per liter, and the 1.09 molar is 1.09 moles per liter. Those are conversion factors. We don't start or end with them. We use them as a conversion. We're going from liters to moles to moles to liters. We have to start with liters. First, we do need a balanced reaction, however, so we can get our mole ratio. We are reacting hydrochloric acid with sodium hydroxide. What kind of reaction is that? You're right, if it's an acid-base reaction, yes. What do we produce in this acid-base reaction? You're right if you said water. And so write out that reaction and balance it real quick for me. Good practice to do this. Hit pause. And hopefully you got this balanced reaction. Sodium hydroxide plus hydrochloric acid makes water plus salt, NaCl. I left out the states just because it's a little messy. But normally you do need to include those. All right, so let's think about our problem again. We're going to start with the liters. We have 0.333 liters of hydrochloric acid. We're going to use the 1.09 moles per liter as a conversion factor. Liters will cancel. Then we can use our mole ratio between HCl and NaOH. And then finally, we will use the moles per liter of the NaOH to get to the liters of NaOH. So it's 3 steps. Again, we start with liters, we go to moles to moles to liters. And here's what it looks like. All right. So again, we started with our 0.333 liters of hydrochloric acid solution. We know there's 1.09 moles per liter in hydrochloric acid. The liters of hydrochloric acid cancel. We're left with moles, ready for that mole ratio. If you look at the balanced reaction, there's only one HCl and only one NaOH in the balanced reaction. HCl needs to be on the bottom to cancel out. 1 mole of HCl on the bottom to 1 mole of sodium hydroxide on top. Now moles of HCl cancel out. Follow your units. Now we have moles of NaOH, but we know there's 1.25 moles of NaOH in a liter. The 1.25 moles NaOH needs to go on the bottom, so moles of NaOH will cancel out. We're left with liters of NaOH. When you put that into your calculator, you get 0.290 liters of NaOH. Again, this was a solution stoichiometry problem. I hope you did well on it. Good luck.